Okay, chapter 5 is on discrete probability distributions. This first slide, here's all the sections that we'll cover. The first one is just probability distributions. Then we're going to do kind of a new way to find mean, variance, and standard deviation and expectation for a specific type of distribution. We're going to also look at the binomial distribution, and then there's 3 other types of distributions. So in this one where it says other types, we'll have 3 others. These ones we'll briefly touch on. We're not going to go into a lot of depth, but one of those 3 others we've actually kind of already done. So you'll see that one of those looks really familiar when we get to there. Let's see here. There we go. Oh shoot. I think I just started my recording over. Or started a new recording. Whatever. Okay, chapter 5 objectives. We're going to construct a probability distribution. We're going to find the mean, variance, and standard deviation, find the expected probability. Then we're going to do that for a binomial. And then lastly, we're going to do that for, these are the 3 different ones that I just talked about that we're going to do, the Poisson, hypergeometric, and multinomial. We've actually already done this hypergeometric one, so we just didn't call it that before, but we did do it. I always like to start with the objectives. I know it's kind of like not something that's super intriguing probably to you, but when we go back at the end of the chapter, you should be able to read through these and go, yeah, I know how to do all 5 of those. So that's kind of the idea anyway. Okay, so is called probability distribution. So we talked about probability, but what is a probability distribution? So what does this word right here mean? That's what we're getting into, that idea. So I want you to read those 3 definitions there. I'm going to just be quiet for a minute and let you read those. You see anything new in there? Anything we haven't really learned before? Not really. We talked about this, or we've never really talked about what this is, but basically all it is all the variables that we have and what their probabilities are. So that's the only kind of new thing there, but I think we already know this idea, right? That all the probabilities need to add up to 100%. And we already know what a random variable is. So we're just going to kind of combine all these ideas together and we're going to make a little table. Okay, so if we were to construct what we call a probability distribution, that's that new vocab word in there, for rolling a single dice, this is what it would look like. We put our variables out there. Our variables are all the outcomes. So this would look very similar to our sample space, right? Okay. And then the probability of each one happening goes underneath each of them. As you notice, all of these add up to what? 1. Yep, they all add up to 1. So if you add all of these probabilities, it should always add up to 1. You know it's not a proper probability distribution if they don't add up to 1. So it's a way of kind of summarizing all the outcomes in each of their probabilities. Now in this one, each probability has equal weights. Each one is 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. But on different probability distributions, it's not always going to be equally weighted. Kind of depends on what we're looking at. So here's tossing a coin. They did the probability distribution here. That's this table. And then down here, they did a little graph of it. So it says, represent graphically the probability distribution for the sample space of tossing 3 coins. So if you toss 3 coins, the number of heads you could get is you could get 0 heads, 1 head, 2 heads, 3 heads. Now where in the world did they get these probabilities from? Well, they looked at the sample space. If you guys remember right from the last section, if you toss 3 coins, you could get head, head, head. You could get head, head, tail. You could get head, tail, head. You could get tail, head, head. And then I could do all these with, instead of H's, be T's. Okay, switch the T's and the H's around. So I don't have them all listed there, but there's a total of 8 different outcomes, and 3 of them have 1 head, 3 of them have 2 heads, 1 of them has 3 heads, that's this one right here, and then 1 of them has no heads. That would be the one that's tail, tail, tail. Okay? So all they're doing here is they're summarizing the different probabilities for each thing into a table. So this again is called a probability distribution. This whole thing right here, this little table is called a probability distribution. And then they're making a little graph of it down below. The graph is kind of interesting. I would call it a bar graph, but it's like a super skinny bar graph. And so I don't know, like for some reason our book does it so it's like they do bars, like they put a dot here and then they just draw a line down to the axes. And then they put the probabilities on the left side. But I don't know, it's kind of weird, so I think it would not be incorrect to go ahead and make these into bars. That would be okay too, if that makes you feel any better. But basically it's showing each probability of each number of each of the outcomes. So these are your x's, and then the probabilities go on the y-axis. So these are your x's, these are your y's. Okay? All right. Mean, variance, standard deviation, and expectation. I think that's our next slide. I hope I'm not missing one here. Okay, so actually, this is a good point to stop. We finished all of 5.1. This is section 5.2, this mean, variance, standard deviation, and expectation. So what is 5.1 about? It's about probability distributions, basically making those tables, and that's it. So it's not very hard to do. You basically need to be looking at all the outcomes and figuring out the probabilities of each one. My favorite probability distribution is probably rolling 2 dice. And so I'm going to go ahead and do that one. So I'm going to pause the video and record this. We're going to start talking about mean, variance, standard deviation, and expectation. The rounding rule that they say here is that the mean, variance, and standard deviation should be one more decimal place in the outcome. I think that was what the same rounding rule we had before. So if the numbers are whole numbers, then the mean, variance, and standard deviation, you go out to 1 decimal place. It says when fractions are used, they should be reduced to lowest terms. So just making sure you get them simplified. Okay, so this is just rolling a dice. And what I want you to see here, and I know this slide kind of came up goofy. I think it's better on my regular one. My regular PowerPoint, it's fine. When it came up on here, it kind of condensed it a little bit. But what we do to find the average, on average, what would we expect us to get? What you do is you actually take each of these and you multiply them. It's very much like a weighted average, okay? So we have 1 has a chance of 1/6. So you do 1 times 1/6, and then 2 times 1/6, and then 3 times 1/6, 4 times 1/6, 5 times 1/6, 6 times 1/6, and then you just add them all up, okay? And you don't have to divide by the total because you've already weighted them by making these into probabilities. So what we would expect to get is actually a 3.5. Okay, that would be the average if we were to roll the dice 100 times and we were to write down all of our numbers. On average, we'd get 3.5. That's what that's saying. Okay, so you take each of these and you multiply them. Now, if I'm going to use my calculator to do that, I'm going to put this stuff in list 1, this stuff in list 2, and then I run my one variable stats. And you got to make sure that you have L1, L2 if you're going to do it using the old calculator. The new one, you put L2 in as the frequency list. Okay? So I want you to get out your calculator and see if you can't run that. Get this average. And then instead of it being mu, when you get your answer, it's going to be that X bar. Remember, X bar is sample mean, mu is population mean. It doesn't matter because they're calculated the same way. Okay? So go ahead and see if you can't get your calculator to do one variable stats on that. So example number 4 says the trips of 5 nights or more. The probability distribution shown represents the number of trips of 5 nights or more that American adults take per year. That is, 6% do not take any trips lasting 5 nights or more. 70% take 1 trip lasting 5 nights or more per year, etc. Okay, so that's what they're showing here is number of trips. 5-night trips, 0, 1, 2, 3, 4, and then what the percent is of each one. So if I said find the mean, I would be finding the average number of trips, right? Because X is number of trips. So the average number of trips where, again, instead of doing this out by hand, I would just put this stuff in list 1, this in list 2, and run your one variable stats. Otherwise, you can times each of these and then add them up if you forgot your calculator. So you take 0 times 0.06, 1 times 0.7, 2 times 0.2, 3 times 0.03, and 4 times 0.01, and then go ahead and add all those up. Okay. On the next slide, you'll see the 1.2. Same type of thing here. So example number 5 is on hold for talk radio. Talk radio has 4 telephone lines. If a host is unable to talk or a talking person, the other callers are placed on hold. So this was the probability that 0, 1, 2, 3, or 4 will get through. It looks like most of the time one person's going to get through, right? Because it seems to make sense. Yeah, most of the time. But these are the other chances for these other things because of the number of lines that this radio station has. So you could then find the variance and the standard deviation by just putting these in list 1, list 2, and run your one variable stats. I can't remember if I put that on the next slide or not. Oh, they show how to do it out by hand. Out by hand, actually, variance and standard deviation isn't too bad by hand. You actually just square each number, then times them by the probabilities, then add them up. But again, I would not do it that way. As I take your time to do all of this, I would just run your one variable stats. X bar is your mean, right? You might want to write that down. Sigma will be the next number down. You'll get sigma sub x. That's your standard deviation, okay, on your one variable stats. That's not this. That's this number here, that very end one. And then you just take this number and square it, and that's going to be your variance. Okay. They're showing out how to do it by hand, but I would run my one variable stats on this. I'm going to go ahead and do that real quick, so I'm going to pause this. Oops.